Today I will design a single phase half wave rectifier by using Proteus software. We open a Proteus software 8.30 and see the surface window, and open the surface window. We in the top of the C we click this open a surface. This is the design page. We also design, so we need a component. So in this design, so we want to pick up a component. In this surface we design, and also by using Proteus software we use PCB design. So we click P, then we pick up a component. In the we see the search box, and name the component which is mentioned in the your paper. Firstly we pick up a transformer. We see another type of we use in this project ideal transformer. Or saturated transformer. We see another type of transformer. So in this project we collect a saturated transformer and click OK. We see transformer is collected from this side, and we also pick up another component. Diode. We collect this diode from library. You can choose any type of diode, but I choose this diode. Then click OK. And then we pick another component, resistor. We search in the search box resistor, and then we see a component, then OK click. Then we place the component in the board, and then we connecting all the component by each other. So we place diode, also resistor. We can flip the resistor by right click and then click rotate clockwise, and then we need a voltage source. We know transformer is working by AC source, so we need AC source. So we click and AC source, AC sign. We know DC and OC, so we need AC sign. We know AC sign is square sine wave, so we pick this and we connecting the source with transformer. In this wiring we use left click of the mouse. The wiring transformer output side connect from the diode. We use one diode because of we need a single phase and half wave rectifier, so we need one diode. Then we connect diode and transformer with resistor. We measure the voltage. We need AC voltmeter and DC voltmeter, AC meter, and AC we need. We see the shape of the graph. We need oscilloscope, shape of the signal, so we need an oscilloscope. We pick up an oscilloscope. And we see voltmeter, DC voltmeter, AC voltmeter, and we place AC voltmeter, also DC voltmeter. How can change the voltage? We measure. We connect in this circuit both AC and DC voltmeter. In this project we need measure the voltage, so we need a voltmeter. We also connect voltmeter, AC also DC in parallel. We need one DC or AC voltmeter. AC unit, basically this AC source, so we need a AC voltmeter, and we need ground. So we connect oscilloscopes. In airport we connect sine wave directly. We see the oscilloscope output sine shape yellow, and output of the transformer we connected B port of oscilloscope. And diode output we connect C port. If we see the half-wave rectifier, we can diode output connect in the C port, because of we see half-wave diode shape will be changed. We see only positive direction, so we connect the diode, and D is connected ground on oscilloscope. We change the value of transformer by double click of transformer. We cannot change the value. I change default value. If we can change, then transformer ratio will be changed, then I will change. We know transformer consists of primary and secondary turns ratio, but we see in the default value in this calculation we cannot change. And I change the value of AC voltage source. We click RMS value and change 10 volt, and DC offset will be 0. We change the value of transformer and we run on simulation. We see the simulation. This is our oscilloscope, direct oscilloscope window, and we need configuration oscilloscope, because see the output of original input voltage, output voltage we need. So we can configure the oscilloscope. We see if we change the cursor shape, then we see the value in graph. If we cannot click the cursor, we not change the output, and we change the oscilloscope knob. We see the phase shift of output channel. We basically in this window I configure the oscilloscope output. Airport is yellow is show airport output, and red is show B port output, and also blue is say we see the channel. In this channel we see yellow. This is a AC wave, that's input signal, AC. And we click cursor, we see the value of graph. We see the color oscilloscope that's in the connected in the simulation, and the output graph we also see the same color will be same, knob will change. Yellow is the channel A, and this is the connected from our sine wave input signal. And we change the output. Blue shape is changed, basically transformer output. We can configure by rotating the knob. We can change the shape of wave. We know this also the output of rectifier. After output rectify, pink or red color shape is output. We see in the video, we see the output oscilloscope pink shape. This is the output of our final. And we off the D port, the channel will be off. If we want to need individual output, then another port will be off. We can off the on another port. In this video we need three port A, B, C. In this video we see if we change the cursor, we shift the value upper and lower, and by rotating the knob we change value the sine wave and input wave also. We can add some meter, voltmeter, and reconfigure the circuit. Also voltmeter change, we see the output. If we on the simulation, then we see the output in the voltmeter. And then now we need a capacitor, because we know capacitor is if we change the knob setting, then the shape will be changed. This is the component mode we selected, and we pick up a capacitor because we know capacitor filter the signal, so we use a capacitor. connect the capacitor in parallelly if we want to need a filter reduce the noise, so we use in the circuit a filter. Basically this we need how the simulation is open and the simulation is complete by simulate software and change the capacitor value. This video will idea how the simulation can run and the simulation on in Proteus software, and we see the output again, and we see if we change the channel, and then we see the output in filter signal. In this video we cover up the how to connect to the component from Proteus wiring and simulate the signal. If you study more and more, and you can give a better idea. If we change the knob setting, then knob will be shift change. If you can change in, then you see how the change and this. Thank you everyone for watching my video. You can more study, you can get an idea where Proteus software is designed in simulation, and you see my video and also get an idea what you can start a simulate file and what do you need. In this video we will cover half wave rectifier with filter and without filter circuit, how can it works.